To solve the numerical problems in radioactivity, we need certain formulae. Now I am going to list out all the important formulae which are required to solve the radioactivity problems. First I will write the formulae one by one. The most fundamental one is half-life. By knowing decay constant, we are able to derive the expression for half-life. So what is the formula? T half. Half-life is equal to 0.6931 divided by lambda. Here lambda is called decay constant. So you should know what is lambda. So by knowing T half-life period, we are able to calculate the decay constant also. Lambda is equal to 6931 divided by T half. So you should know what is T half and lambda. T half is nothing but half-life period. Lambda is called decay constant. Both the two are required to calculate the each factor. Are you clear? Another important formula is number of radioactive nuclei undecayed. Number of radioactive nuclei undecayed. To calculate this factor, what is required? The formula is n is equal to half power of n. N naught is required. Here you should know what is small n and n naught. That n represents the number of radioactive nuclei undecayed. அதாவது எவ்வளவு நியூக்ளியை ரேடியோஆக்டிவ் நியூக்ளியை இன்னும் அழியாமல் இருக்குன்னு கால்குலேட் பண்ணுறது தான் n. So here small n is called number of half-lives. Number of half-lives. Small n. Are you clear? And then what is n naught? N naught is the number of atoms present. Number of atoms present when in the initial stage, when the time is present, so clear, when t is equal to present at t is equal to 0. In the initial stage, when the process is not yet started, when t is equal to 0, at that time you have to find out the total initial number of atoms, that is called n naught. The same kind of formula that can be written in terms of activity. Here R is equal to half power of n into R naught. Here what is R? R is called activity. So at any instant, R is called activity of the radioactive sample. Activity of the sample at any instant, t. Are you clear? To calculate R, what is required? N is required. Already I have written what is N. What is R naught? R naught is nothing but initial activity. That can be written as, what is this? Initial activity. Initial activity. That is when the time t is equal to 0. So these are all the important things which are required. And we are going to write few more formulae also. So this is the third one, and then this is the fourth one. This one can be taken as fourth one. So while asking the problem, they will ask several steps to calculate the problems in different steps. Different kind of formulas are required. Collectively, you should know all the formula. Only then we are able to solve the problem. And then we are able to write one more formula by knowing R and R naught. Are you clear? What is that? The fifth one is lambda. Decay constant can be found out by knowing these two formulae, that is lambda is equal to R by n And one more formula is also there, that is R naught by N naught. Know both the two formulae, both of them will give the same answer. And then now I am going to write the next formula, seventh formula. You should know one basic relation, that if half-life period is divided by mean life, you will get this fractional number, decimal number 0.6931. Always the half-life period is lesser than the mean life. That's why you are getting the number like this. The value will be lesser than 1. From this expression, we can get the other expressions also. To get half-life, multiply this factor with tau, 0.6931 into mean life. So this is the formula. By knowing the value of tau, mean life, we are able to calculate the half-life. And we can write one more formula to get tau. Tau is equal to half-life divided by 0.6931. So these are all the formulae which are available one by one. Now I am going to write the most important formula, number of half-lives. Number of half-lives. To calculate the number of half-lives n, the very easy and fundamental formula is total life. What is this? Total life divided by half-life period. Total life divided by half-life period, T half. So this is the expression. Are you clear? By knowing this two, we are able to calculate the small n value. While solving the problem, then only you know the importance of all the formulae. And then, what is the another formula? Total number of the amount of substance undecayed, the total number of atoms that left undecayed, number of atoms undecayed in terms of fraction. Are you clear? In terms of fraction, to calculate the value in terms of fraction, which formula to be used? N is equal to N naught 1 by 2 power of n. So this is the formula. Provided if you know the initial number of atoms, this one must be multiplied by this factor, you will get the number of atoms undecayed. Clear? In terms of fraction can be calculated. Are you clear? So these are all the important formulae. By using this, you can solve any sort of problem. After calculating this fraction, what you have to do? Number of atoms decayed can be calculated in terms of fraction. What we have to do? 1 minus n naught 1 by 2 power of n. So this is a formula. Calculate this part and substitute, you will get the answer. This value to be subtracted from 1, you will get the answer. Okay.